Hi guys, Dr. Burns here. We're going to take a look at our last new lesson for Chapter 3 in Unit 1, which is on boxplots. So boxplots are another type of display we can use when we're working with numerical data. And boxplots don't show us all of the data points the way maybe a dot plot would, but they give us sort of a summary of the numerical data. And that summary that they give us is called the 5-number summary. So let's get into that in this lesson. Please make sure your cell phones are put away and turned off, that you're listening and not just watching the closed captions, and paying attention to what I'm saying very closely. This is a fairly short video, but it is important, and even if you've done boxplots in the past, I find this tends to be sort of a confusing topic for statistics students. So let's get into it and see how we do. So the 5-number summary, first of all, is something we'll get when we work with it. We're going to either be given the 5-number summary or we're going to get it from StatCrunch, but it's a series of calculations that sort of summarize that data. And it's 5 specific numbers in this order every time. So it goes the minimum for the data, and then Q1, and then the median for the data, and then Q3 and the maximum. So the 5-number summary, if you're given that and you know that, okay, someone tells you this is the 5-number summary, it will always follow that order, and those are those 5 specific numbers, and that's never going to change. So we're going to use a box plot to display this. So the box plot gives us a visual representation of the data, numerical data, using the 5-number summary. And like I said, you will either be given the 5-number summary or you'll use StatCrunch to calculate it if you need it in a particular problem. The directions for finding the 5-number summary are right here, and we'll go over this and practice this again in class, but here it is. You're going to go to something called the Summary Stats menu. So make sure you put a little star by this because we're going to use this tomorrow to find the 5-number summary. Let's do a quick example here. So the following table reports the average monthly high temperatures for St. Augustine, Florida, and Mount Pleasant, I think that's Michigan. And we did this example in a previous question where we talked about these two cities and looked at their temperatures for each month over a given year. So you notice that for each of these we've got 12 months, so January through December. I'm going to go ahead and pull up StatCrunch, and I'm going to show you how to get this 5-number summary. So I went ahead and put this data into StatCrunch. So column 1 is St. Augustine and column 2 is Mount Pleasant. And by the way, you can label the columns to kind of keep things straight just by typing in them like that. So to get the 5-number summary, I'm going to go to Stat, Summary Stats, Columns, and then I want to get the 5-number summary for both cities. So I'm going to select St. Augustine. Notice it populates there, and then I'm going to hold the Control key down and select Mount Pleasant. And then down here, it will pull up all of these statistics for both of these data sets. So N is the sample size, the mean, the variance, the standard deviation, and a whole bunch of other things that we don't necessarily need. But I wanted the 5-number summary. So you've got a couple options. You can either just click compute, or you can unhighlight and highlight the things you want it to actually calculate only. I'm going to hit compute and just show you what this gives me if I don't make any changes. By default, it gives me all of this information about each data set. But the 5-number summary is right here. Now notice StatCrunch does not give this to you in order, so just be a little bit careful when you put it into your notes. But you've got for St. Augustine your minimum, Q1, your median, Q3, and your maximum is 90. And by the way, it gave you the range too. I don't need that for the 5-number summary, but there it is. So I'm going to go ahead and move this aside, and I'm going to write this information into the notes here. So for St. Augustine, it looks like my minimum was 67. Q1 was 71.5. The median was 80. And then Q3 was 87, and then the maximum was 90. And then for Mount Pleasant, I've got 57.5 for my minimum. I'm sorry, that's not the right number. Let me fix that. think that was actually the median. See, I'm looking at the wrong thing in StatCrunch, so let me make sure I got it right. So the minimum was 29. And then Q1 is 42.5. The median was 57.5. And then Q3 is 75.5. And then the maximum is 83. So StatCrunch will also make the box plots for us, and we're going to have StatCrunch do that for us in class. But for right now, I want to talk about what the box plots look like and how they represent these 5-number summaries. Let's start with St. Augustine. Well, actually, you know what? I'm going to start with Mount Pleasant, only because this one's a little more expanded, so it's a little easier to label all the parts. What you've got here is you've got this box, first of all. So I always, when I draw these, I start with the box if I were doing one by hand. The left side of the box right here, that's going to be Q1 for that 5-number summary. And the right corner of the box, that's going to be Q3. And then the line on the inside of the box, and it may or may not be in the middle, it depends on the shape of the graph, but that's going to be your median. All right, so I always start with that. And if you look at Mount Pleasant, you'll see that Q1 we said was at 42.5, and it looks like my box plot might be slightly off, so I'm not sure where I got this graph from, but it's about, we'll go with it, about 42.5. We can take that. And then Q3, remember we said was at 75.5. And actually, I did notice there was a little typo in what I put into StatCrunch. So Q3 actually was 75. I just recalculated it just now. So that would be 75, not 75.5. Not a huge difference, but you can see that that would be, oh, okay, 75. I'll take it. Close enough. Median is at 57.5. There it is. Oops, somewhere like that. 57.5. Now, let's talk about the minimum and the maximum. So that's where things get a little bit trickier when you're talking about a box plot. In this graph, we drew the whisker. So sometimes these are called box and whisker plots. We drew the whisker out to what's called the lower fence. So the whisker goes out to one of two places. It either goes out to the lower fence or to the minimum, whichever it approaches first. In this example, the minimum was 29, so that's where it ended up, was at 29. And because there was nothing past that in the data set, there's no outliers. I'll explain this a little more on the next page. On the other side, you can see I drew the whisker out to the upper fence, which also ended up being the maximum, which was 83 right there. I'm going to skip the St. Augustine graph for now, only because it's a little bit cramped in my drawing here, and I want to talk a little bit more in the video about these fences. So let's talk about the fences a little bit. So the fences are what we use as our cutoffs for unusual data values when we're looking at a box plot. This is kind of how you make a decision on whether or not something is a potential outlier. How do we calculate the fences? So the lower fence is always going to be found by taking Q1 minus 1.5 times the IQR. And if you have any points in your data set that are past that value, that would be considered an outlier. Similarly, the upper fence is going to be Q3 plus 1.5 times the IQR, and that would give us anything past that ends up being our upper fence. So what we're going to do when we draw these is we're going to draw our whiskers, so that's the lines on the outside of the boxes, to either the minimum on the left side or the lower fence, whichever the data approaches first on the left side. Likewise, on the right side, our whisker will be drawn either to the upper fence or the maximum, whichever we approach first. And if the data set has any points outside that, they would show up like this on the graph, and they would be dots past where those fences are. Now, in this particular data set, I don't think I had any outliers. In fact, the graphs that would have been generated from StatCrunch didn't have any dots for either cities, which means there weren't any outliers. So example 2 says, find the upper and lower fences for St. Augustine from the previous example. Were there any outliers? So let's calculate for St. Augustine. So let me go back to St. Augustine. Let's start with, we need the IQR. So for St. Augustine, the IQR would have been, I'm just writing it here so I can see the numbers in front of me. The IQR would have been 87 minus 71.5. All right, so that gives me 15.5 for the IQR. Now, to calculate that lower fence, I'm going to do Q1. So the lower fence is going to be Q1, which for St. Augustine was the 71.5, minus 1.5 times that IQR that I just calculated. So let me put that into my calculator, and I'm getting a value of 48.25. So here's how you know if there's any outliers. Are there any values in my data set for St. Augustine that are below 48.25? And there were not. So that means there are no outliers on the lower end. All right. And by the way, if we have the graph, the box plot, we can see that because there's no dots past the graph. You need the entire data set to make the box plot in StatCrunch. And so if there were any outliers, they would have shown up out here, but there were not. There's not going to be on the other side either, but let's just verify it. The upper fence then is going to be Q3, which was 87, plus 1.5 times the 15.5. Again, let me calculate that. And I'm getting 110.25. So again, I would go back to my data set and I would say, all right, are there any values in the data set that are higher than 110.25? And there are not. And again, if there were, it would have been indicated in the graph by a dot past that whisker, but there weren't any, so we could tell from the graph there weren't any. But I want you to also see that in the data set up here, there are no values that are bigger than 110.5. So there were no outliers on the lower end or on the upper end. And we'll talk more about this in class. This idea can be a little bit confusing, but we'll talk more about that and how it fits into the box plot.